And hello everyone, welcome back to a new video. So today we'll be learning about sets. Let me just zoom in here because I saw in one of my previous videos that the text was a little bit small. Yeah, I think that should be seeable. So sets are basically unordered lists, they're basically unordered lists that cannot hold duplicates. They can be mutated though, so they're lists, not tuples. They just can't have any duplicates and they're unordered. So they're very fast compared to lists. So if you need something faster than a list and it doesn't have to be ordered, so the way you ordered it doesn't have to be like that, then you can go for a set since it's, So here we can create a set. So I'm just going to go and call this S. So S is equal to, and here we can create a set. Usually this would be if you were to do this, then this would be a dictionary. So you put something here and like that, and I will compile as a dictionary. So if we were to go python free main.py, you can see it will not compiled, it will run without any problems. But if you want a set, then you can just have this. And you can just put your things in here. So let's go 1, 2, 3, 4, 5. Just to show you how the unordered list or set looks. And good, I should probably print that out. Print this. Run that, and as you can see, we get 1, 2, 3, 4, 5. But if you also wanted to go like this, so 4, 3, 2, 1, then it would just give 1, 2, 3, 4, 5. But just remember, it is unordered. So if you don't get 1, 2, 3, 4, 5 and you get like 5, 4, 2, 1, 3, then don't worry about that. It's because it's unordered. So sometimes you will get a strange order in return. As you can see, it can't hold any duplicates since there's 4 as a duplicate, 3 as a duplicate. We basically, So that's kind of how a set works. You can also make a set from a string. So you can do something like set. And here we can go hello world. If you do that, then as you can see, it has turned it into a set. And also as you can see, now it isn't ordered anymore. It is ORLDW space HE and not HELL, because remember, can't have duplicates. OWO can't have duplicates. RL can't have another L there. So yeah, you kind of get the point of it. You can also transform a list into a set by doing this. And then you can just add your list here. So if we were to go 1, 2, 3, 4, 5, that was your list. Then as you can see, it turns it into a set. Just take note that just because this gets converted into a set does not necessarily mean that this is a set. This is a dictionary. So if we were to run this, okay, I guess that wouldn't, we have to get type probably. As you can see, it sees this as a dictionary. As soon as we add an element to this though, so 1, 2, then it will see it as a set. As you can see right there. You can declare an empty set though by doing this, set, and then that will also be seen as a set. So as I said before, it is mutable, which means you can add things to it just like with a list, just maybe not in the exact same way. Let's just remove these. And here let's create a set, and we can call it, or not call it, we can just go 1, 2, 3, 4, and we can go s.add, and let's add 2 just so I can show you. And then we can also add a 5. If we were to run this, as you can see, it's 1, 2, 3, 4, 5. 5 has been added. This 2 has not been added because then there would be duplicates. Remember, no duplicates, it's unordered. That's what you need to remember here. so it's fast, but there is some drawbacks then, so no duplicates. So you can see we added 5 right here. And that's kind of how you can add things. If you want to remove something, we can then do something like this. s.remove, and let's just go here, and let's say 2. Now it's your so let's just say 2 here. Oh gosh, sorry about the new keyboard. I'm really not used to it. Okay, here we go. So if we say remove 2, then it's going to remove the number 2. It's not going to search for that index. It's going to search for that number, because it's going to search for that element. So if we were to add in hello here, and if we were to run this just to see that hello is there, then we can put inside this remove hello. Do that, and then hello would no longer be there. So this removes the element you search for, not the index. One thing you might notice at some point is, let's say for example this, and you want to remove 5. Take note that there is no 5 in that set. We run this, then we get an error, and you get a key error 5, because 5 doesn't exist. So to bypass this, you can use discard, and this will try to remove the element and not throw an error if it doesn't exist. So as you can see, it just tried to remove it, wasn't there, didn't throw an error. We can also go and just to show that it does remove things, we're going to put 3 in there. As you can see, 3 is no longer there. So I recommend that you always use discard unless you are specifically searching for an error. But otherwise you can just use discard. You can also empty a set by using clear, so .clear, and that will empty the set entirely or completely. As you can see, it's an empty set. And of course, just like with list, you can loop through a set. So for ins print I. I'm going to comment that out. Do that, as you can see, it gets 1, 2, 3, 4, 1, 2, 3, 4. You can also search it, so of course you can go here and say, instead of that we can say if, and let's go here and say if 5, let's go 3. If 3 in S, so if that number is in S, you can say 3 is in set S. And it will return 3 is in set S because there is a 3 right here. Change that to 6 and it will no longer run because there is no 6 in that set. So let's create another set. And here we can say 1, 3, I meant to say 3 there. 5, 7, 9. And then we can call this odd. Here we can call this even. And we can make this equal to 2, 4, 6, 8. We can then create a union between these two. A union is when both of these two are being merged together. So if you want to merge sets, you can use a union. So let's create a union variable, and we can say that is equal to odd dot union, and we can say even. If we do that and print out union, as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Both of these two Both of these two have been merged together. If we were to add another set here, so maybe let's say prime numbers, so prime, I have no idea what prime numbers there actually are, but if I'm correct, it should be 2, 3, 5, and 7. Those should be the only prime numbers under 10, if I'm correct. I can't remember, but I believe those are prime numbers. But it doesn't matter. It doesn't matter. So what we can do then is we can try and find what is inside of both of them. So I'm going to call this enter, and enter is going to merge these two, not merge them together, but it's going to return the values that exists in both of the sets. So if I go odd dot intersection, that's how you spell it, and we go prime, and then we just print out enter, run that, as you can see we get 3, 5, and 7, because 3, 5, and 7 is found inside of here and inside of here. So if it's found in both, then return it. Let's say we want to only return the value that does not occur in both of the sets. What we can do then is, instead of saying intersection, we can say difference, and I'm just going to keep it in enter. As you can see, it's 1 and 9 because 1 and 9 are not found in both of these. But take note that it's going to search for what is not in both of these, but it's going to keep this as the primary one because it's odd dot. If it was prime dot, then 2 would have been included and these would have been excluded. So if we were to, just as an example, do that, just swap the 2 and then run it, then we will get 2 because now this one has been set as the primary set. So it's going to see what is in here, and it's going to return what is in here but not in here. So that's kind of how it works. There's also another one which we can go and say symmetric and then symmetric difference. Now if we were to run this, as you can see we get 1, 2, and 9. This time it was like the difference, but now it returns what's in both. So 2, 1, and 9, it only occurs once in both of these two ones right here. So symmetric difference returns all of those that only occur once and not in both. We can also do this, so odd.update, and then we can just use prime. This should not be here anymore, we should just display odd. So we can go odd, and if we were to run this, as you can see we had 1, 2, 3, 5, 7, 9. So it adds these to this, so it adds two sets together, kind of like union. Intersection update, if we run that, then it's 3, 5, and 7. So it only adds to this right here what is found in both of these. So if it's found in both of these, then that will be added here. We can also go, instead of intersection update, we can go difference update, do that, and it will return 1 and 9 because 1 and 9 does not occur inside of prime. So it only returns what is not found inside of both. And this is of course the primary one, so it won't add what is inside of here in there. So we can go symmetric underscore difference underscore update prime. Run that and we get 1, 2, and 9. So basically what that means is we get 1, 9, and 2, but we don't get 3, 5, and 7 because these happen in both of these two. So yeah, but remember it changes this variable, this odd one right here. It changes it, we don't put it inside of a new variable. So if you do that, it's permanent. We can also do a few extra mathematical like things here. So you can go set A, and I'm just gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9. Then set B, I'm going to make equal to 4, 5, and 6. Then here we can say set B dot subset, or not subset, dot is subset, and then we can say set A. Run that, then we get true. Now, if you don't know this type of math, don't worry. Basically, we're just checking if B exists inside of A. That is what we're doing most basically here. If you want me to draw it for you, I'd be happy to. So, how sets kind of work is, if I have to give you a basic example, is, let's say this right here, that is set A. So this is set A. And it has the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you can think of this right here as set B. So let me just change the color to set B. And set B is inside of set A, so we can say is subset. So this is a subset of set A. Of course, I'm not going to go too deep into this. If you want to know more about sets, then I recommend you go maybe watch a video on it, because it's mostly just math like things. But it's not a big topic. It's just, just so you know. So this basically, in basic terms, this exists inside of this. So yeah. You can also check if A is a superset of B. So here we can just go superset. So B is a subset of A, and A is a superset of B. If we run this, is going to return true or not. My problem, or my mistake, that should be A and this should be B. Now, okay. Now that that's switched, it will say true. A is a superset of B because A contains everything inside of B. So it contains everything inside of B and more. So if we, I just removed that drawing. Let me just quickly redraw that. Then there's set A, and here is set B. Now, A is a superset of B because A contains B and more. So imagine this is a plate, and this is a sauce bucket. It has like soy sauce or something in it, and A has things like fish and, sushi and stuff in it. That's a fish. So B is a subset of A because B is inside of A, but A also contains more things than B does. But A also contains B. That may be a little confusing. The easiest way to think of it, B exists inside of A, so A is a superset of B. If you want to check if something is not a subset or a superset, you can go say, is this joint? And set A, set B is going to return false because B is a subset of A, and A is a superset of B. But if we were to go here and make this a 7, make this a 10 rather, and we were to make this maybe 15 and this maybe 14, then it will return true. It will return true because what is found inside of B is not also found inside of A. So just like with this, you can also copy and things like that. So if we make set B equal to set A, and we were to print out then, as you can see, set B is the same as set A. But if we were to say set B dot add, and let's say 99, then A will also have 99. So it's just like with a list. If you're basically referencing that list or a set with B. So if you modify B, A will also be modified. If you want to copy it into a new set, you can just say set A dot copy, and that will copy the set. And so if you modify set B, it will not modify set A along with it. If you want to have a set that cannot be modified after it has been made, so basically it's a tuple set or a tuple version of a set, then you can go here and say frozen set, and if you print set A, it will still give you a set, but now it will be of type frozen set. So if you were to say set A dot, and let's say add 99, then you get an error because it's a frozen set, so it doesn't have an attribute add. You can't add to it. And that's where I'm going to leave it with sets before I get too deep into it. Thank you all for watching. I hope you all enjoyed and do now understand what sets are and how they work. Thank you all for watching. See you all again in the next video.